Let's have some fun. This is another tutorial video for Thinking Particles release 7.3, and we are going to discuss MEL, our scripting language, in here. However, in contrast to the other videos, this is more of an explainer video, so you won't see me typing in code and making up code and doing typos. So we are going just to explain how we did that one and going through the code to understand what's going on. So let me just dive right in and start with bringing up the TP setup we have here. So here's the TP setup. You can see there's nothing too dramatic going on. There's no operator that creates particles or anything. We have a particle group, or actually we have two particle groups and one dynamic set here. We have this object node that lets us pick any object in the 3D Studio Max scene, and this object is fed into the expression MEL. Let me bring up the code so that we understand what's going on here. So let me start right up here, and I'll do a comment. You should always do comments on your code so that you later on know why you did the things and what the variables mean. So the first entry is getting the object. And because it's the first entry, it means it is multi-threaded. And multi-threaded means we are accessing information in parallel. So if you have a machine with 100 cores, we are accessing 100 particles at the same time. We are accessing 100 vertices at the same time. We are processing 100 colors and so on and so on. So the next entry we created here is our vertex particle group or particle group. So the particle group, let me just explain what we did here, is we create this input, and that will give us the selector here where we can just pick the particle group where we want to create the particles or access particles. So that's all. We have these two things. When we compile, we get the input. Then we have some variables we declare here. The first is our vertex position. So we want to store the vertex position here. The second one is our vertex normal. And the third one is our particle ID. And when we create new particles, we want to know or access this newly created particle. And then we have our color. Actually, to be more precise, vertex color. So this is our variables where we store this stuff. Now let's request the information we actually want from the system. So the first call is asking for, let's see, vertex position. So we call here vertex position, and we store this in the variable spos, which we defined up here as a vector, so 3 values, x, y, z. You might ask, how do I know what this function does and what I need to supply? Very easy. Put your cursor here. Press the selective help button down here as help, and you get the information automatically opened up here for our objects in geom function. So we created the objects input, and this input offers us some functions to access data like mapping channels, face data, vertex data, edge data, and so on. And here is the description of what we need to supply to the function and what the information we can acquire is here. So let me go back here. So let's move on to the next query. So we are asking for the vertex normal. So this call will give us the vertex normal of our objects we go through in parallel, and also the information of the object itself is going through in parallel. So we are accessing all the vertices in parallel. So we have this sorted out, and the last one is the vertex color. So here we ask for the vertex color, and we store it in our vcol variable. So now we have all this information from our vertex. And the next thing is, if our color, and I use the mathematical max function, so that actually works as brightness. So if our brightness is above 0.1, that means it's not black. We go in there and create a particle. Where do we create a particle? We use the vertex particle group. So we create it in our particle group we have picked there. And we create this particle at the position as pos, which we got from this function. So we create this particle, and if we were successful in the particle creation, we get a particle ID back that's bigger than 0. Then we are going to set the size of the particle that we just created, and the size is calculated based on the brightness. So black means 0 size, and 1 would mean the maximum size. So I just multiply it by 5 so that we get something to look at. So that's our code. And now let's have a look what it does. So we have applied the vertex paint to this, and let me just choose a non-black color. Let's start with this color here, and we'll just paint here. And we can see the brighter our color gets, because it fades out, the bigger our particles get. So let me change the color to something like that. So we could control even the objects we create or meshes we create when we paint based on the color, for example. So we can say blue is trees or teapots or whatever we want to create. So let me just create something like this, and we paint here our particles and paint here our particles. So you might ask, why can I see in real time when I paint here? So what we did in Thinking Particles, let me just go back to Thinking Particles. What we did here in the master dynamics that we turned off edit on the fly. Usually we do not recommend doing that, because it means for every change you do here, you restart the simulation. So what we did here is restarting the simulation, creating particles, and so on. So usually you just want to have this turned on so that we have to start the simulation manually. But right now, for the sake of this tutorial, it's fun to paint on the object and create some extra particles here just by painting. Okay, here we go. So that's about it. I hope you like this explainer video and it gives you some interesting ideas. Also keep in mind, all the sample scenes in our tutorials are already available with your purchase of Thinking Particles. We ship MEL with over 100 sample files covering nearly every aspect, including vertex color access. Thank you for watching this video. Hope to see you again. Goodbye.